we did so far, right? Because I want to explain to you the way the capacitor charge and discharge. If I'm not mistaken, we talked that capacitance in series and parallel, right?
Perfect. It's almost series. Yeah, I think it's about series.
Yeah, we didn't borrow, we got the two.
I didn't make somebody come and do them good.
Yeah,
But so it-
All right. So just as a quick review, we said that the capacitor is a device that has the ability to what? Store charge, right? So the capacitance of any capacitor is equal to what? What is capacitance equal to? The capacitance is charge stored per unit voltage. That's okay? Right? And I also said that the capacitance is made up of two parallel plates. What's in the middle? Dielectric, right? Right? And and how you find it? How you find capacitance using the dielectric and all the other properties? Epsilon by epsilon naught by area of the plates over distance between the plates. What is epsilon again?
8.85 by 10 to the power.
Right, and the next epsilon is a dielectric coefficient, right? So it's based on the dielectric inside here. Was the relative value. After this, we start to look at right? We looked at doing small calculations with capacitance in series. Right? We looked at capacitance in series and we said it 1 on C is equal to 1 on C1 plus 1 on C2. Right? I sent a small handout in the group that has this notes as well, right? It's a big one and the small one as well. Right? In the end, I'll combine all those smalls into a nice summary, right? And parallel, I didn't show you all the proof for that. Did I? I didn't show you the proof. All right. Let me just show you the proof for parallel, right? Right. What do we know happens in parallel, Nikela? What do we know splits up in parallel? Voltage, right? So if I have a voltage being supplied here, then set them up then, Nikela. Yeah. Parallel is what? Current. Like, here's I, here's I1, here's I2. Right? And remember I told you, right? Well, I'm gonna write that first, right? Remember I told you I is equivalent to Q, right? They behave the same way. So Q is equal to Q1 plus Q2. How you find Q again, Anthony? How you find Q? So in terms of capacitance and voltage, Q is equal to C by V, right? So what will Q1 be? Q1 here will be C1 by V. Why is V? Because V constant, and then C2 by V. And when you divide by V, you'll get C as. Right? So that's the formula for capacitance in parallel. Right? We pull proof in the notes, right? Yeah. Yeah, you gotta be able to tell me I pulled it up. Huh?
She got me. Who takes you? She got me. It don't make sense. Just say, and I think that she got
No, like you know, but you only give us five suppose problem because. Yeah,
Hey, anyway, first expecting to win money.
Yeah.
You're gonna give up. Yeah, you're gonna give up and I'll fuck her.
Alright, so what yeah, you'll get back on this double for sure.
Sorry, boy. This place. I just want.
Right, so these are the things here that we know for capacitance so far. Alright, so let's go to the worksheet and do a couple of these. Alright, a new I still have to huh? No, we now start module 1. Module 1 is electrostatic, electricity and magnets, right? So there's like 1 to 2 that you read.
Oh, they didn't want to see. I didn't trust that.
Yeah, 1 to 2. Whenever I start, I make you all come on this already. If I went to learn right, check in the group, please. Check in the group and you will see a worksheet. It's from some of the questions I gave you last week, but I just isolated because I know most of you might need notes on everything. Like a Daria.
What is it? What should you see?
He hates Indian people, but he's like really nice.
You know what?
Alright, ready? You all seen it there? Right, so go to the handout. Right, go to the handout and then in the group, check in the group. Capacitance. Alright, let's start. Number 3. Huh? Someone make up some other stuff behind of other things. Yeah, but there's not part of it. Huh? I have it, but I'm changing numbers like. Alright, number 3. Here, look at it. Number 3. Two capacitors, one with the capacitance of 6 and one with a 4 connected in parallel. Find the equivalent. You can do that mentally. Number 3, yeah. You're done? Right? Right, so because they are in parallel, you just add them easily, right?
So yeah,
When you add 6 and 4, you'll get 5. Right? Capacitance in parallel, you add them up, 6 plus 4, that'll give you 10 microfarads, right? Go again, number 4. If you can't see, just pull up the try number 4, combination of series and parallel. Number 4. Ready?
That was. Well,
Number 4, work it out.
Yeah, one of us. Outside. Yeah, let's say long time up there. Yeah, get that.
Yeah.
Sure. Yeah, because you did one time the same thing. I don't know.
You got it out wrong. It's okay.
Excellent, excellent.
Right, three capacitors are connected, C1 and C2 in parallel, and this combination in series with C3.
Hey, I got it.
That's one. Right, C1 is 2. I just squeeze it in a little 2 there. I'll squeeze it in a little 3 here. And C3 is 6. Right, find the total capacitance. Right, what we have to do, add up the two in parallel. 5. Right, so that'll be 5. And then 1 over S is what? So that's 1 over 5 plus 1 over 6.
Yeah.
So that's 11 and 30. Flip it over, right? 30 and 11.
Oh, wait, what?
Otherwise 1 on C. 1 on C, so you have to flip it over. So it's 30 and 11. What I have on the number 4. Slide down, just go down and see. Up. 30 and 11 is out.
Yeah, you're just wrong.
Huh?
You still have the answer wrong?
Alright, number 4.
You lock that up?
It's yours.
Oh, you get to, oh, yeah, yeah.
Sorry. Wala lang lock down sa I did not pass yet. Alright, next number 10.
Yeah, I don't know.
I didn't show you a chart.
Yeah, yeah.
Number 10. Seven doing 20. Number 7. Number 10. Online, all okay? You understand any answers yet? Aria, click Aria, or Anthony, are you getting through that? Kyra? Nalia, you working it out? No, you're not. What's your right so far? You're not saying it now, right? Hurry up, do number 10 fast. You shirish. What are you doing? Take your time, work it out.
Yeah, that's what, yeah, that's it. What is up? Yeah. It's definitely. Because remember, it's 3 different values. So what it's like,
Are you ready?
No.
Right, we have 3 capacitors. That's true. Right, online, if you don't mind, you can send out answers, please. If it's not too much trouble.
And then the ratios.
Yeah.
Yes, yeah, right.
So in chat with the names. You know, chat is
Yeah.
together.
Yes, sir, you charge the for like, you know, some people that able to be different.
Right, so you got it. Calculate the charge on each capacitor. So the first thing you need to get is the capacitance, the overall, right? So that'll be 1 on C is equal to 1 on 2 plus 1 on 4 plus 1 on 8. Don't worry with the micro, it will calculate after, right? So don't worry with that too much. So you'll, how much you'll get? 4, 5, 6, 7, and 8. But remember to what? Remember to flip it over. Right, so it's 8 on 7 microfarads, and you want to get charged. Right? Q is equal to C by V, which is 8 on 7. 8 on 7 by 10 to the minus 6 by 120. Because it's micro, right? What is that? It's one, that's right.
1.37
1.37. Anybody else get up?
Yeah.
Should we check shoes? You got up?
So I got that one.
Should we have nothing in your book? Yeah, sure, you know? Alright, why, let's get up, are you working? Right? The charge is 1.372 by 10 to the minus 4. Wait, you know? Yeah, come to the morning of his name, man. Now, he's coming to morning.
Really, I don't know.
Huh?
Like if I don't the name, I don't know. Let's take a one.
All okay with that? And then we have to find V1, V2, and V3, right? Right, V1 will be 1.372 divided by. Yeah, this number you're gonna cancel out.
And for the engineering today, I'm just going to do that. I'm going to fail. Yeah, I can feel it. I'm listen, I'm in a group with ideas.
Huh? Yeah. But if you want, you can convert it by 10 to the minus 6, right? So it's going to cancel out. How much is B1? No, I just divide, I know, I can't write my figure that much. Just divide Q, I divide Q. I make B something Q and C. Yeah, it doesn't make it 3 times.
You want what? You want
How much?
So.
68 points? And when you say points. Okay, 68.6. Right, and find B2 and B3 the same way, please.
Yeah.
Only remember, I have no class on the first, right?
Yeah.
Right, the first.
Take on take back. Take it, so you must.
No, we.
So that I took in last game,
Yours.
so this is naps, and they used it. I know it was already good.
So people are making fun of me.
Right, B2 is what? B2 is what? 34 point, point 3, and then B3 is what? And that will make sure you're working out 120, right? What? 17.1.
Yeah.
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 Up? Sort of, yeah.
My school like that,
Alright, let's go again. Right, we're coming away from this and just doing one past paper.
Yeah, you're up. I have to that's part of it. I'll still do the benefits. Singing my class.
Why you do that?
I don't know, but when I get one of the strongest of the team, and he was against everybody else. It's not even get like six like big yeah. So you get fun. I just get 5 points.
That's cool.
That's
Yeah.
Yeah.
That's all we need. Can I go again?
So the whole thing is that trans for real? That's not it's not very fun. And it's terrible.
Right, this is 2010, I think. Joy diagram, let's work it out. Sean, Benaya, come on. Last one, and then we go into chart and then this chart.
Yeah.
Take a picture. Take a picture. Okay, no, yeah.
No on Instagram because it's been popping.
Oh yeah. Let's try this one here. Take this one. Right? Yeah, combine it. Right? Take your time and simplify it circuit. Just like our 5 minutes.
Oh wait.
Just simplify it. Actually, you're going to need to pass one to something. Right, join diagram.
Yes.
My cousin's Irish. Say no.
Right, so simplify the circuit. It's easier to it's much easier to simplify it in parallel, right? Simplify those in parallel and then work it out.
Oh my god, I think what? I don't know.
Okay, you're right.
But I wrong.
Okay, so that's really about your.
So in parallel, they would go. I mean, if you're free, singing last year.
Okay, and then come to that.
Yeah, it's really me.
Right, Mariah, you'll see it, Mariah. Online, please send another answer, just one, please.
So we.
So sweet.
Just send it to me.
Bye bye.
Actually, we don't have to. I'll keep up. I think it's got to do comment.
Oh, yeah. Yeah, he didn't come today. And then it's what's in it.
Got you, yeah.
Like after.
I think you need
Feel a little tired. Can you tell? Sorry.
The white one.
You want
You have the accent. Salary.
Say it, just do it. You know, it's in class.
That's it. Yes.
You like it.
Nikolai.
That's the final one charge, right?
Right, yes, so to get it charged, you have to have the total capacitance and the voltage, right?
Say a blocking question.
Yeah, so what is it?
Alright, so.
You can make that. No, wait,
Can I start this now? Are they cutting room class to do this? Let's do the first part, right? So in order for us to find charge, right, we know that charge is capacitance by voltage. And please don't forget to put in micro, right? If I simplify these two, I'll get 12. If I simplify these two, I'll get 24. Right? So the overall capacitance will be 1 on 12 plus 1 on 8 plus 1 on 24. Right? So that's 2, 3, 4, 5, 6. What's that again? 4.
Yeah.
Right? So the total capacitance is 4 microfarads. Right? Now they want us to find charge. So that'll be 4 by 10 to the minus 6 by 6. So that's 24 microfarads.
6 people did.
They give you the voltage.
So how you do the question?
1 on C is 1 on C1 plus 1 on C. So that's,
So if I have like the parallel.
yeah, add the parallel.
I did. I said the one.
Oh yeah, add the 12 and 24. Yeah.
And then
Plus 9.
1 on 9. Oh, what's parallel formula? Add in.
so I put 1 equal. I put 1 on 6 plus 1 on 8. Yeah. And then again.
Yeah, we did.
I guess that okay. So
That's it, I get one, I get both.
So you got 1 on.
So 1 on 6 plus 1 on 8.
We get 36 from
No, he add the always the calendar.
So that's how I'm confused. Okay, yeah, I can't.
Because they
now I
parallel.
understand. Yeah, they
That's the
parallel.
And that's me, that means, right, so yeah, we can't not to mix up resistance like
Interesting.
are you okay with that? Nikolai, are you okay with that? Right? How much charge is stored in 8 now? Huh? 1 on C is 1 on 12 plus 1 on 8 plus 1 on 24. Pardon me? Yeah, 6 on 24.
Yeah, 2.4 by 10 matter. So that.
Huh?
24. By 10 minus 5.
Which one? Yeah, right. All right, 24. Michael.
Oh, okay, right.
Right, next part. Right, so Sean. They want to get it charged across.
Yeah, but you have micro, microfarad.
Right?
No, wait.
Part 2. Part 2. Part 3, I mean, part 3. Part 1 is 4 microcoulombs. Part 2 is 24 micro, right? Right, they want us to get it charged here. Right, so they want it charged across this one. So we know that charge is equal to voltage by what? Right? What's the voltage across 8? How we know that? But I thought voltage in series is split up.
Yeah, you know, it's.
Split up. So this voltage, was split up here and here. Right? So the question is, right? Instead of going and do all of that, right? What happens to charge in series? Charge in series is the same, right? And charge in current is the same. That's not gonna love it. Hold on. Huh? Right, so what is the charge in this circuit flowing? Huh? 24, right? So the charge is 24 microcoulombs. Correct? So Nalia, since charge is the same in series, what is the charge flowing here? Across this capacitor. 24 as well. So the answer for part 3, the first part here is 24. Yeah, charge is the same because it's the series circuit, right? So therefore, how would I get PD Shivish? Huh? How would I get it charged? Which is? 50. 50 is what? No. What's the formula for P? Yeah, P is what? Yeah, just rearrange it now. Q over C. Right, so that's 24 micro over 8 micro. So you end up with 6. Sorry, 3. 2, sorry, 3. Right, so it's 3. The last part.
Okay.
Half 8, man. I'll set them now.
Wait, for real?
Alright, hurry up. Last part, 4. Last part. Find each other. It's 10 micro.
Thank you.
Find the charge on the 10 microfarad.
So it's not minus 4, right?
But I know I'm trying to get rid of it. And every time you say, anyway, people are like, I guess 10. Yes, exactly. You're like, we don't have food. See the best. No, I don't. Yeah, see,
Alright, so last one. Right, if you had voltage out, you would recognize here, right, the voltage across that was right, it would have been 24 and 24, which is 1. Right? So the voltage across this is 1 volt.
Are you sure, sir?
What's that?
So you should say 10.
What?
that is just
No, the voltage is 1 volt, that's when charge. Right? So if you do it right, oh, you know what's your answer? I thought. When it combines 10 and the 14 is 24. Right? And it's divided. To get the voltage. Right? So the voltage across.
Maybe we can use this next one.
Right, what you see, right? Across these two capacitors, when I take off these two and combine them, I got a total of 24 microfarads. Right? I am trying to find the voltage across here. So we know that from the formula, voltage is equal to charge over capacitance. The charge in the circuit is 24 microcoulombs. So it's 24 micro over 24 microfarads, and you'll get 1 volt. Question asks the charge, right? So the charge, if you rearrange the formula again, it'll be capacitance by voltage, which is 10 microfarads by 1. So that will give us 10 microcoulombs.
Yes.
Right? So instead of saying what Tavisha answer, which was correct, she get all right. Right? Well, I know where it comes from, right? I'm sure she will. Actually, she will.
Oh, wait, you know, that's what AI generation actually. Yeah.
Alright.
Like, still when
Why that? Because like, I show you exam. Yeah,
Yeah, no, I think somebody else was wanting notes. Why is that Fernando Nashi?
Same thing why I see on the like this. You know how long it is generate? 10 Alright, let's go again. Right, so we want to take a look at how a capacitor charges and a capacitor discharges, right? So we're gonna create a reference.
Yeah.
See, that's correct.
No, it's really
All right, next one.
So press on the speaker out loud, so you know, we went, it's really bad. It's just.
All right, head up. Charging and discharging of the capacitor.
Right, to the university. Yeah.
Right, so we're gonna take a look at charging and discharging of a capacitor, right? Right, let's take a look at how a capacitor charges and discharges, right? If you wanna write, go ahead, but I'll put my notes and I'll show you where it is, right?
Yeah. But then,
What? Wait a second.
Why do you think carpets are there?
Ready?
These are completely different entities.
Like, what is the shit?
You see that?
Hi, stars. Hey, we don't know who on there. So we can check the participants. Let's.
Yes, take a check. We do. We love them.
Yeah. It's fine. No, we don't like that because
Alright, ready? So good. How does this? So we have to learn about charging and discharging like a capacitor, right? So we're starting firstly with we're taking a look at charging, and we want to see how three quantities behave. We want to see how current behaves, right? How voltage behaves and how charge behaves. We want to take a look at how those three things behave. Huh? This is our explanation.
We should write it down.
It's in this diagram missing in notes, but everything else in the notes, but this diagram missing. Right, so you can go ahead and write it down probably. Right. Ready?
Oh, yeah.
I don't feel a little organized.
What you say?
Say, what have you walking down now? Here, like this school. Yeah, I wanted that next one.
so you have something else like and I go in, but it's only same as not to at the same time. So this voltage, they put our 5A at the same exact time as Nashville's Bazaar. 4 p.m. Not even any morning, it's 4 p.m. Who wants to go on the 5K 4 p.m. but the sun shines so bright? You go. I'm not going.
Wait, wait,
Nashville.
you might not go. Wow, we have to be there. Crazy. What a crazy. I'm gonna choose.
I was thinking of Halloween party.
In primary school, I was dressed up as Smash.
I don't really know.
I know. And what's the next one?
Are you ready, Olivia? Alright, so I want to explain how the capacitor charging, right?
Yes, right, I can remember.
Hey, well, let's stay quiet and people online complaining all the real talking.
Sorry to be strong.
Alright, ready? Nikhil, watch here, please. Alright, so here's a circuit. Here we have iron. We have a two-way switch, right? So the switch could either be here or here. Alright? So when the switch at A, the alternating capacitor will be charging or discharging? Charging, right? Because the capacitor connected to the supply, and when it's at B, it begins to discharge, right? So let's see how current, voltage, and charge behaves during the charging phase. All right. So connect this circuit. First thing to flow is what? Current. So as soon as I connect it, positive, negative, the electrons begin to flow. So current will flow, right? So as soon as I connect the circuit, the current in the circuit is the maximum, right? So the current flowing in the circuit starts at its maximum value, which is I naught. Right? So the current starts in there. But across the capacitor, though right now, do watch here. Everything in the notes is just a sketch diagram, right? Watch this here. Because you gotta be able to reproduce and explain this, right? So when it connect the circuit to Shabara and Sean, watch here now, right? When it connect the circuit, the first thing that begins to flow is current. So electrons starting to make its way across the circuit, right? Is there any charge here? No. Right now, there's no charge. Is there any potential? There's nothing, empty. It being charged, right? There's nothing in it. Is there any potential difference here? No. So initially, these two at zero, this at maximum. But as the electrons start to build up here, right? That plate develops a negative charge, right? And since this plate develops a negative charge, what would it do to electrons here? Yeah, right? You want that next to the negative terminal. The electrons will move here. So the electrons will move here, and here develops a negative charge. And in turn, because of that negative charge, it will push the electrons away, right? So it will push electrons here. So what will happen now is that charge will begin to build up here. Yeah.
So when I tell you, right, they put the resistor and the capacitor on the same wire.
Yeah, you can do that as well. Yeah, you can do it as well, but just it won't be charging. Right? And when it connects here, it's still in the same circuit. If I take and put this here, that's the same circuit you just tell me about. Right? Right? What I was saying then. Right. So as the electrons build up here becomes negative shikarish. Now the phone is just water, right? Here becomes negative and here becomes positive. So because of that, there's a potential difference. That's okay? So now a potential difference begins to build up. A charge begins to build up, right? But here's what happening. Because of this potential difference, it acts as resistance. So the same amount of electrons not going to be flowing per second. So the current will begin to decrease. That's okay? And then this value will start to build up and build up and build up until it reaches a maximum value V naught, Soraya, right? When it reaches V naught is comparable to P. So if these potentials are the same with current flowing circuit, no. So when it reaches here, current reaches almost zero. It doesn't reach zero, almost zero, right? Because the value here doesn't exactly be the same as this. It'll be close. All okay with that? And then as time goes along, what is happening to the charge? Charge. So more and more electrons building up, right? And because the electrons building up, we have this potential difference, right? So these two behave the same way and this behaves in reverse. You all see that? So it will continue to happen until this potential difference is close to or the same as this potential difference. Then no current will flow because current must flow from a high to a low potential, right? If both are the same potential, no current will flow.
So,
Yeah, close to zero.
the capacitor is the same, similar to the
Yeah.
source.
You're okay with that? So everything here has to do with charging. Now, any questions online? Now I'm going to put it to P. Right? During this phase is called what, Shivish? Discharging. So let's see if we can figure out how current, voltage, and charge behaves. How do you think the current will behave? Huh? It'll behave Sure.
No, wait.
But remember, it's fully charged.
So, and the access will be different.
Huh? So would it behave just like this? Because it will start at the maximum and then start to lose current. As you lose current, your potential difference will drop. And as you lose potential difference and current, your charge will also drop. All right. So everything is kind of the same except for this one during charging. Are you okay with that?
So, and this is a lot of negative.
Kind of, it's like a reverse polarity. Right? But you wouldn't really. You got a reflection now, yeah.
The access is good. Like the x-axis, yeah, like that.
I got it.
Yeah.
Yeah.
So
I got my equation. Right? So because of the equation, I'm not going to put it like, but I'm going to go a whole negative time.
So he just looks like a
No, no.
Right.
This equation will be different from those two.
This is the for your little tax space.
Saturate. That is correct.
So she's not.
Yes.
It's not. So am I smart? Everybody's smart. I mean, yeah, everybody's smart.
Come on, copy that down. Copy that down.
Nobody can believe you when you say that. You see, this is correctly built in the phone.
Are you writing that down? And copy all that.
Take a picture.
Yeah. Because I want to put some definitely up front. Yeah. So what do you put it up front? Yeah. Yes, definitely up. I'm jumping the up. Yeah.
Okay, please. Right.
I thought you were inspiring something like that.
Yeah, I want to give it a copy that down now. All right, watch this here. You all may or may not recognize, but these are exponential curves, right? These are exponential curves, right? 1, 2, 3, and 4. So it will be I is equal to I naught e to the minus t over RC. Right? Huh? So this here is the equation for discharging. This here is for discharging with voltage. Alright. T is time, and I'll explain what all these things are. Right, watch this here. 1, 2, 3, and 4 are the same formula. Right, but Hanaya, what does the formula here look like? Pay attention, Hanaya. Right, the formula here is a little bit different, right? Is positive. Nah, close there. 1 minus. Well, that wasn't close. I don't want the one who just did it, right? Is yeah, by exponential. Two kind. Yeah. So this is the reflection of the exponential. Yeah. So e to the x is here, and there's a reflection of it. All right. So the ones that you really have to remember are these two here. Voltage and charge during charges, right? Because these two have the 1 minus, right? Right, and I want you to remember T is time, of course. RC is something called time constant. And R is resistance. And C is the capacitor. All right. I'm going to explain what is time constant, right? All right, so these are the graphs that we have to know. We got to be able to explain the graphs, and of course, have that little stuck up there, right?
Yeah, I think that's what. You did that. I did that.
C is the capacitance, R is the distance, T is time. Copy it up. I want to next.
Oh, yeah.
Yeah. She's not everybody, yeah, then they can't tonight to get
All right, number 1. Right, not much people. I just want to point out something, right? I don't want that up. Right? Not much people sometimes, right? Sometimes you have to solve Yeah, you take ln, right? Sometimes, right? Sometimes they might ask you to solve for t. So whenever you have to solve for t, you have to take something called ln, right? So I can bring I here. Right? I can bring the I naught on this side. And in order to solve this, right? Remember, you want to make t the subject of the formula. So what you do is you'll take ln on both sides or check a calculator and you'll see the inverse of E is ln. So you can bring this here. When you bring the E across, it becomes ln. Right? And the way to remember it is look at the calculator. No, Leah, look at E on the calculator. And above E, you will see ln. Yeah, no, they put in non-match people. Right?
Yeah.
Speaking Nalia? Right. So always remember the opposite of E is ln. And you'll be left with minus T RC. Right? All you have to do now is carry across the RC and the minus sign. That's it. So the opposite of E is ln, like how the opposite of sine is sine inverse. Same thing. Okay? So I say remember that, right? So T will be equal to minus ln I on I naught all over RC. Okay? Carry across, sorry. Multiply. Huh? It don't matter. Yeah, this for this version. But it don't matter. It's how you make it subject to the formula. Right? Because sometimes you have to learn to do this. All right? So the opposite of E is ln. Just remember that. Whenever you're moving E, it's like ln. Whenever you're moving sine inverse, same principle. All right. There's a formal definition for time constant. Is what? Now, time it takes to go to 1 on E of the original value. So make a note of it. It's in the notes, but just in case you do it now and you want to know what it is. The time constant is the time taken. Time taken to go to 1 on E of the original value. Right? So 1 on E of the original value. Right? Time taken to reach 1 on E. 1 on E of the original value. All right. Let's try this one. This is question 3 on section 2. All right. Take a little read. Go to the worksheet. Number 3 in section 2. Question. I take a little read because you might think I to do much more than this, right? Alright, ready? Take a little read. A capacitor capacitance 8 right? I just put in a little letter by it so we know what it represents. It's connected in series with a resistor, just like my diagram, and a voltage battery, right? The capacitor is initially uncharged. Calculate the time constant. How do we find time constant? Right, no, but that will be no, that's how you find time. Time constant is tau, right? So yeah, the symbol is tau. La fancy low. Right? And right, time constant is R multiplied by C. How much is that? So that's 10 by 10 to the 3 by 8 by 10 to the minus 6. How much is that? Yeah, that's like plural and singular. Every symbol of plural and singular. I mean,
So there's that 80 by 10
18 by 10 to the minus 3. What's the SI unit?
30 seconds.
Second. Right? Because of course, time on time, right? They will cancel and then you'll. Right? Next one, that's part A. So tau is 80 by 10 to the minus 3. Right? Next one. Determine the voltage across the capacitor. So they want the voltage across the capacitor 5 seconds after it's connected. Think about it. Right? Determine the voltage across the capacitor 5 seconds after the circuit is connected to battery. So are we using charging or discharging formulas here? What are we using? It's now connected, right? And that's charging. So we're using the formula right here. V is equal to V naught by 1 minus e to the minus t RC. What's the SI unit for time again earlier? Second. Right. Anybody can tell me what's V naught? What is V naught? What is the maximum possible voltage? 20, right? The voltage of the whole circuit, right? 20 by 1 minus e to the minus t, and we work out RC already.
I said minus B with 5.
Yeah.
Right? So that's 5 over what? 81 to 0.08. Right? 1, 2, 3. Right. Put the voltage calculator from over here. Put the voltage calculator from over here, right?
Okay.
This goes.
Right? So what I mean, right? So you get 20, so it means after 5 seconds it's fully charged. Right? Anybody can see why? What's the time constant? 0.08, right? That is time taken to reach 1 on E, which is a big fraction, right? So after 5 seconds, you're almost sure that you're fully charged. Okay? That's why I got 20. So at 5 seconds, the battery is fully charged. Check out C now. After the capacitor is fully charged, the battery is removed and the capacitor is allowed to discharge. How long will it take for the capacitor to drop to 1 volt? Right? So we know that V is equal to V naught e to the minus T on RC. And what is V in this case? 1. What's V naught? And then T is trying to find T and RC is 0.08. Right. So non-matched people come right here. Right? Come right in formula I gave you and work it out. Everybody, whoever doing math, we can do it a long way, right? Let's make T the subject, carry across 20, take line on both sides, use the power rule. Right? Yeah, same thing I do then. Well, I'll let you get the experience. That's really. Right, don't forget the minus sign, right? How much is that? 0 points. 2, 4. Alright,
Yeah.
let's go again. What? I thought it's half past 6.
I don't wanna.
You said that to be like 7, no?
Yes, you ask me external.
Alright. Alright, so we have one small thing to do in capacitance again. That's your homework. Read up on energy stored. Right, and then we'll put it together and do some past papers next week.
And then